Imagine a cold, crisp can of Pepsi lying in the fridge. You grab for it and crack open the top with that familiar crackling sound, and finally take a long, refreshing sip. There it is, that signature Pepsi flavor, a perfect balance of sweetness and fizz, familiar and thirst-quenching. It's a taste recognized all over the world, enjoyed by millions every single day. But have you ever stopped to think about what actually goes into making that can of Pepsi? How it's created and shipped with the same flavor worldwide without even the slightest of differences. Behind that simple blue can lie a complex system of science and strict quality control. And today, at Whole Process, we're going to find out all the details on this long journey. But what company is behind the iconic Pepsi? It's PepsiCo. It was formed as a corporation back in 1965 after the merger of Pepsi-Cola Company and Frito-Lay. The company, which is headquartered in New York, manufactures beverage concentrates and syrups. It also has independent bottling partners, which purchase the concentrate and carry out the dilution, carbonation, packaging, and distribution. When it comes to Pepsi's core ingredients, carbonated water takes the center stage, adding up to a total of 90% of the drink. Other ingredients include that signature caramel color, along with a measured mix of phosphoric acid and citric acid to balance the sweetness. Interestingly, it also includes a small dosage of caffeine. But where does the sweetness in Pepsi come from? The answer to that is the use of high fructose corn syrup in the US version of the drink, while in the international market and makers, Pepsi mainly uses sucrose. In certain regions, though, there are ingredient variations, like the sugar-based Pepsi, which is common in Mexico. Other popular versions of the drink are the diet and zero sugar ones, which rather than using sweeteners, use artificial sweeteners like aspartame instead. However, even if there may be multiple variations with the flavorings themselves, one thing is for sure. All ingredients sourced and used by PepsiCo are FDA and EU approved following local food safety laws in the countries the manufacturing plants are based in. But how does the manufacturing process begin? Well, the first step is actually the creation of the dense syrup concentrate, which acts as the core flavor base for our sweet drink. It is a dense syrup that carries the essential taste profile of Pepsi Cola, including its sweetness, acidity, color, aroma, and caffeine content. Unlike the final bottled product, which is mostly water and carbon dioxide, the concentrate contains the most flavor-active ingredients in concentrated form. It all also contains the same key components in all: caramel color for its deep brown hue, phosphoric acid and citric acid for its sharpness and tartness, caffeine for the stimulant, and for that unique kick it gives. But all this manufacturing process takes place at PepsiCo's controlled facilities in areas like Ireland, North America, and more. Each plant operates under strict confidentiality to protect their own unique taste. Along with that, high-level food safety concerns are kept in mind, and every ingredient used goes through multiple checks. Accurate measurements are made, and the ingredients are mixed according to their secret formula, which is only known to a small number of PepsiCo scientists. During production, computerized mixing systems ensure that temperature, mixing speed, and ingredient addition sequences are tightly controlled. Each batch is homogenized to ensure that there is a complete distribution through them all, and the final flavor is the same in every bottle. Have you ever opened a Pepsi bottle and had it taste differently to another bottle? Probably not. That's because of the care taken in executing this step. Once blended, the concentrate is transferred into sealed food-grade containers, which are typically stainless steel or even high-density polyethylene drums. Each of these drums are labeled with batch codes for traceability and sealed to prevent contamination or tampering. From here, these drums are shipped under hygienic and secure conditions to PepsiCo's authorized bottlers around the world, where they will later be diluted with treated water, sweeteners, and even carbon dioxide to create the final finished beverage. But that's not quite where the story of Pepsi ends. In fact, there's a multitude of steps left. Water is by far the largest ingredient in Pepsi. It typically makes up between 85% and 90% of the finished beverage by volume. Because of this, The purity, taste, and mineral balance of water directly influences the overall flavor. Even things like the carbonation behavior and microbiological safety of the drink get directly affected by this. Every Pepsi bottling plant begins its process with rigorous water treatment, which is essentially done by transforming the local municipal or well water into a consistent neutral base suitable for beverage formulation. But there's a twist. Water from municipal sources usually contains minerals, chlorine compounds, and even organic materials that could all work to alter Pepsi's taste and stability. Even small differences in dissolved solids or hardness can affect carbonation and the way flavor compounds express themselves. Therefore, Pepsi bottlers must bring the water to a consistent purity level that meets both local regulatory standards and even PepsiCo's internal global specifications, which are typically much more stricter. So how do they go about this? Each plant uses a multi-stage system combining physical filtration, chemical adjustment, and disinfection. The specific sequence is standardized across bottling operations worldwide. The first step is coarse filtration. This step removes suspended solids like sand, rust, or even organic debris using multimedia filters. But all of this is also constantly checked to make sure that the processes are being carried out as expected. Automated sensors measure conductivity, flow rate, and even pH. Not only this, but water samples are also constantly checked for microbiological activity that could end up spoiling the whole batch. Periodically, these samples are sent to certified labs for comprehensive chemical and microbiological analysis. Once approved and fully tested, the clear water is stored in sanitized stainless steel tanks and piped over to the syrup mixing area. The syrup mixing stage here is arguably one of the most important parts of the process, and in our opinion, the most interesting one as well. Inside the bottling plant, the sealed drums of Pepsi concentrate are opened under hygienic conditions and pumped into stainless steel mixing tanks. The tanks are then fitted with mechanical agitators and temperature controls to ensure complete blending. The operator adds the correct volume of purified water and a prepared sweetener solution to this large mixture. When it comes to the mixing sequence itself, it is automated through programmable logic controllers that regulate everything from pump speeds to flow rates. This is great because it battles with removing any and all natural human errors that may happen. After blending, technicians measure the syrup's Brix value. Never heard of that? Well, that's what we're here for. The Brix value is known as the percentage of sugar solids in the drink. A typical cola syrup ranges from 55 to 65 Brix, depending on the product variant. The pH and acidity are also checked to maintain proper flavor balance with the acids present in the concentrate. Temperature is also carefully controlled, usually kept between the small range of 20 to 25 degrees to aid sugar dissolution and maintain viscosity. Too much heat could degrade flavor compounds, and too little could lead to a generally poorly done job at mixing. But before this syrup can be used in beverage blending, a sample is sent to the labs. Analysts here verify that the syrup meets the set standards. Once this is verified, the batch is released for transfer to the proportioning system, where it will be mixed with additional treated water and carbonated to become finished Pepsi. So how does this so-called blending even take place? Modern bottling plants use automated inline blending units, which continuously mix syrup and treated water at precise flow ratios. They even have flow meters and PLS-controlled valves to maintain exact proportions, which are typically around 1 part syrup to 5 parts water in the general industry. Of course, Pepsi doesn't share this information publicly though. After blending, the liquid is kept at a chilled temperature, usually between 1 and 4 degrees Celsius to prepare for carbonation. But why is this done? Well, because lower temperatures enhance the CO2 absorption later on in the process. The beverage passes through inline carbonators, where filled liquid and CO2 gas are mixed in a pressurized chamber. Now, while CO2 is the main reason why there's fizz, there's also other reasons for the use of CO2, like the fact that it enhances the mouthfeel through the microbubbles and acts as a mild preservative. It also goes as far as to affect acidity slightly, contributing to the flavor perception we have. But the clock is ticking. Once carbonated, the beverage must be filled into containers immediately to prevent the gas from escaping. Have you ever had a day-old Pepsi? Well, that's how it will taste if you let it sit too long after the carbonation. Aluminum cans arrive preformed and sterilized from the approved suppliers, while the plastic bottles are often molded on site, depending on the facility's ability. But to ensure food safety to the next level, all containers pass through automated rinsing systems that spray sterile water or ionized air to remove microbes or any small free particles. The filling machines kick into full gear. They maintain an equal internal and external pressure, preventing foaming and CO2 escape. But do you know the crazy part? Production speed ranges from 30,000 to over 100,000 containers per hour, depending on the package size and line capacity. These bottles then get immediately capped and seamed airtight. In fact, automated torque sensors verify each cap's tightness, and seam gauges ensure perfect sealing. Now come in the final quality checks. Sample, head over to labs to get checked, and flavors get tested. Sensors track everything from CO2 concentrations and even container integrity. Once all the quality checking ceremonies are complete, the batch gets approved to be sent out into the real world. But before a perfect blue bottle of Pepsi Cola can be released, it gets added into a batch with other bottles. Each production lot is logged with date and time of production, QC readings, and even concentrate and syrup batch numbers, so that in the off chance something bad happens, the manufacturing process can be traced back internally. Bottles and cans are grouped into sequences of 6, 12, or even 24 for larger ones, and then packed in large boxes. Once the last box is packed, they then get shipped off across the country. To think, one simple bottle of cola can hold a past of so much effort, innovation, and technology. What seems like a simple everyday soft drink for most of us is actually the result of over 100 years of tweaking and refinement. So the next time you crack open a cold and crisp can of Pepsi to go for that familiar refreshing swig, you'll know exactly what it took to get in your hands. Do you like Pepsi or Coca-Cola? Let us know in the comments below. If you enjoy this video, remember to like and subscribe, and as usual, we'll see you in the next one.